Hi guys, welcome back to the Art of Server. This is a Seagate Mach.2 drive. This is a hard drive with a new innovative technology that has been around for about 4 years. And it's recently become available on the secondhand market like eBay. What's special about this hard drive is that it is basically two smaller hard drives stacked on top of each other. So even though this is a 14 terabyte drive, it's actually two 7 terabyte drives in the same enclosure, sharing the same SAS interface and the same motor. But each half set of platters has its own actuators or heads. So it's referred to as a dual actuator drive. Here's how Seagate explains it.
Traditionally, we have a single actuation system so that all of the heads are moving together. In a dual actuator technology, we essentially double and have a second actuator stacked on top of the first that allows independent motion between the top set of heads and the bottom set of heads.
Now, I haven't been a fan of Seagate in a very long time, not since the days of their old Cheetah SCSI drives. That was sort of obligatory because, cats. I have a lot of issues with their more recent products and I don't usually recommend them, but I gotta give it to them. I think this dual actuator idea is brilliant. Here's what Seagate says about the advantages of this technology.
Mach.2 technology has three key benefits that it provides to users. It provides doubling of the IOPS that the user can access random data on. It allows 2x the performance of sequential bandwidth for streaming applications. And it is the first hard drive technology to introduce parallelism technology, which enables two independent streams for dual channel access.
Now, on the first point about doubling the IOPS, I think it's important to clarify. As far as I understand it, it's not dual heads that can read the same set of platters. Each set of heads has their own independent set of platters. So in order to double your IOPS, you need your data to be spread across both sets of platters. If your data only resides on one of the two sets of platters, your IOPS is no better than a single drive. Similarly, for the second point about sequential bandwidth, your data needs to be spread across the two sets of platters in order to benefit from the higher throughput of reading or writing data to or from both sides of this drive. So to reap the rewards of this technology, it's important to organize your data in a very specific way. Now, the last part is what I found somewhat confusing. They mention dual channel access, and this immediately made me wonder if they're talking about the secondary SAS port on these SAS drives. You see, SAS drives have a primary data port, which is right here, and a secondary data port, which is right above here. And this is often used in dual SAS expander setups to enable redundant paths, and in some cases of SSDs, increased bandwidth to the drives. So it got me wondering, is this how they are implementing access to the second drive inside the Mach.2? We're going to find out later in this video, but Seagate also says this.
The goal is to enable users or access into storage devices to have multiple pathways into the device, which are independent.
So they say there are multiple pathways into the device that are independent. Once again, it sounds kind of like they're talking about the secondary SAS port. So let's go find out exactly how this works and spin it up in the server. Here is my server. I have a LSI SAS 3008 HBA controller here. This is a SAS 3 12 gigabit controller. I'm using this specifically because the drive, the Mach.2 drive, is a SAS 3 drive. And I've had some problems in the past where Seagate SAS 3 drives don't work with SAS 2 or older controllers. I don't think that even with the dual actuators, we're going to saturate a 12 gigabit link, but I wanted to start this with a 12 gigabit controller just in case we run into that kind of compatibility issue. So I basically have this cable connected to the Mach.2 drive. This cable is powered via a Molex adapter to a SATA connector right there. And this cable is a single port cable. So there is no secondary port on this cable. So that secondary port on the drive is not going to be visible at all. So if the way Seagate is implementing this is to use that secondary port, then we're not going to see both sides of this drive. But if they're not doing that, then we might end up seeing both sides of the drive. So we're going to find out what happens here. But just wanted to point out that this is not a dual port setup. So the secondary channel on that SAS drive there is not connected to anything. Okay, so we are only connecting on the primary port of that SAS drive. So let's go ahead and power this guy on. All right, guys, so I've logged into the server that just booted up, and let's go ahead and run lscsi and see what we see here. We actually see both Seagate drives, or the both halves of that 14 terabyte drive. That's actually really interesting. So that means that the discussion we had earlier about the dual channel it's not about the secondary SAS channel. They're actually just using one channel and presenting both drives to the system. So, oh yeah, look over here. So if you look at the SCSI address, you see the 0 and the 1. So that's the LUN number. And so, you know what? Let's take a look at the logs, and we can kind of dive into that a little bit more. But so that's good news, though. That means that even if you are using these drives in a single port system, you don't have the dual port type of system, it's still going to work. So that's actually really great. All right, you know what? Let's go through the logs. So I'm going to look for messages from the driver. I'm going to look for SCSI layer messages, and then the SCSI disk level messages. So let's see what we get here. All right, lots of stuff. You know what? Let me blow this up and let's scroll. Okay, here we are. All right, so we're starting out with, so these are, I think, just the SATA ports. So we got host 0 through 3, that are SATA ports. There's USB storage, which is probably my boot drive, and that's host 4. The CD-ROM drive is connected to host 0, which is, that SATA port. My SanDisk UltraFit USB drive is on host 4, which is this USB storage. So yeah, the host 4 is my USB boot drive. And that's all related to the same thing. Okay, here we are. So here's the MPT3 SAS driver loading, and it is at PCIe address 8300.0. So here's the first instance of this driver, right? So CM0 is the instance of the driver attached to that SCSI controller, or the LSI HBA, basically. Oh, okay. So here we have SCSI host number 5. So we'll keep that in mind. Host number 5 is going to be this HBA controller. And sure enough, here on host number 5, we got 5000. So these are SCSI addresses. These are basically unique addresses within the system that are assigned to each device in order to be able to uniquely identify devices. And so here we see the first instance of a Seagate drive. Here is the SAS address to that device. And then we see another one show up as SCSI address 5001. And so this last number in the SCSI address, so in case you don't know, these 4 different numbers that are part of the SCSI address, they start with the host number. The second number is like a bus or channel number, so like if you have multiple buses on a controller. So the first number basically is associated to the controller. And this is, if you have multiple buses or channels on that controller. Most modern controllers don't seem to have that anymore. And then the third number is the SCSI target. Each SCSI target has a SCSI address, or sorry, not SCSI, SAS address. And so here's the SAS address that's associated with that. And so you'll notice that this is 5001, 5000. And so they're the same SCSI target, so they have the same SAS address here. But the last number, which is the LUN number, or the logical unit number, is different. And so the way Seagate is implementing the access to the 2 halves of this Mach.2 drive is by presenting them as different LUN numbers. So the first one is LUN0 and then the second one is LUN1. So okay, that's really interesting how they're implementing this. So that allows them to not worry about the secondary SAS channel, because if you use the secondary SAS channel, I believe that it shows up with a secondary SAS address. So it would basically be, instead of a different LUN number, it would be a different target. That's not the case. Well, that's not what Seagate is doing with these Mach.2 drives. They're simply implementing it as a different LUN within the same target. And so you can see the devices come up here, and so sure enough, they are those 6.83 or roughly 7 terabyte drives, 4K sector sizes here. So okay, so that's really cool. That's very interesting how they're implementing this as basically a different separate LUNs within the same target. All right, so now remember I plugged in the SAS3 HBA there, so I just want to make sure that it's linking up at the correct speed. So let me just run lsiutil -s, and sure enough, here it is linking up on that one connection. You can see all the other connections are down. That one connection is linking at 12 gigabit speeds, and it sees both of these disks. And here, of course, you can see the bus target and LUN number here as well. Let's run next smartctl. And wait, hold on, let's see. They were showing up as dev SDB and SDC, so let's run on SDB first, smartctl. Let's just take a look at the smart data. Okay, so vendor product number here, 7 terabyte drive, 4K sector sizes of 70 to 100 RPM, 3.5 inch drive. You know, it is a SAS drive, and health status is currently okay. Drive temperature is 35 degrees. Elements in grown defect list is 0, which is good. That's a healthy drive. There's nothing wrong with it so far. No indicators of any faults or errors. And the error counter log here shows no errors detected so far. There's been some writes and reads on it already, but no errors so far. Non-medium error count is also 0. So these are all very healthy things. All right, so this drive actually looks fairly unused. So I bought this drive as a kind of refurbished or used drive, but it doesn't look like it's actually had much use on it. So let's look on the other side of that and see what we see here. So same 35 degrees. Everything is pretty much the same as we saw on the SDB side. Yeah, so far, I mean, these drives are super healthy. So no errors anywhere whatsoever. So yeah, so that's the smart data on these drives. Let's go ahead and run some benchmarks. I want to run some benchmarks on this thing. So, all right. So let's use FIO, and we'll run it on SDB first. And let's just do a sequential read test. We'll use direct IO. And for sequential reads, it's more interesting if we use something large for block size. So I'll use a 1 megabyte block size. IO engine lib AIO. And I think we can just do, not trying to run any rigorous testing here, but so I'm just going to run a 15-second test. And with one process, IO depth 8, I think is enough for a hard drive. Just call this a speed test. All right, let's see what we get here. All right, so we're looking at about 272 megabytes per second. That's pretty good. And that's kind of within the typical expected range for a single spinning hard drive, right? So let's repeat that on SDC, which is the other side. All right, so on this side we got 258. So it's a little bit lower than the first half. I was kind of expecting that both sides would have, identical performance, but there is a slight difference. It seems like the second half is a little bit lower. I don't know. Let's keep running some other tests and see if we see the same pattern. So instead of read, let's do a write test. Let's see if we see the same pattern here. All right, so for the write test, we see 266 megabytes a second. Now let's check that out on the other side of that drive. Okay, so now we are seeing 256 megabytes per second. So yeah, it's similar pattern. We are seeing that the first half of this drive seems to have better performance, slightly better performance. You know, that's like maybe what, like maybe like 5% or so. So that's interesting that they're not identical. And I'm not sure why that is, because they are independent heads on their own set of platters, right? So, well, anyway, that's the sequential test. Let's do some random tests. So I'll do a random read here on the first half. Oh, you know what? Sorry, kill that. You know, random reads are more interesting when you use smaller block sizes. So let's do 4K block size. Okay, so the average IOPS is 138. Okay, so let's do this on the other side of that drive. Okay, so on the other side, we are seeing 131 IOPS. What was it before? In the last run, it was 138. So yeah, a little bit off. And again, this side seems to be just slightly slower. Okay, you know what? So let's put these two halves of the drives together in a RAID-0 and see what we get. Can we double the performance? Let's see, I have SDB and SDC. So I'm going to use Linux software RAID to assemble a RAID-0 out of these two halves of the drives. All right, so I'll call it dev md0, and this will be RAID-0. We'll do assume clean, so we don't do any kind of initialization. RAID devices, there are two, and they are dev SD, B, and C. Okay. All right, so we have a RAID-0 device now. All right, so let's go ahead and run some of those benchmarks again. So let me see if I can just call one back here. I want to do the read test. Okay, so we'll run the read test on MD0. Now remember earlier we saw something like 270 megabytes per second on one side and like 250 or something like that. So I'm hoping to see something like the sum of those two, right? So somewhere above 500. Let's go. All right, bandwidth 517 megabytes a second. All right, so that's pretty impressive, you know. And this is why I was saying, like, I'm actually pretty impressed with this idea of this dual actuator thing, because hard drives are far away from achieving something like this, 517 megabytes a second. You know, so if you've seen my older video called the 259 rule, where I kind of give you some rule of thumbs to help you figure out how much bandwidth you need and stuff like that, that 2 is the 2 gigabit for hard drives, and 2 gigabit is roughly about 250 megabytes per second. This is double that. For the longest time, hard drives are just, you know, you could connect a modern SAS3 hard drive on a SAS1 control and you would see no performance difference, because they just don't need that kind of bandwidth. They just can't achieve that kind of throughput. But this Mach.2 actually can. I mean, this is actually getting very close to the limit of 6 gigabit SAS2, right? And this is a SAS3 drive, so it can go up to 12 gigabit, but I doubt it's going to get anything close to that. But this is at least very close to the limit of SAS2 drives. So that's actually kind of cool. All right, let's do the write test. Now, one thing I noticed, 517, if you think about this, let's go back up and look at our sequential numbers again, because I think it's not quite double. Okay, so we're looking at 272 plus 258. So if you were to add that up, that would be 530. So this is 517, so we're not exactly achieving double the speed, but still not bad, right? Okay, so let's do the write test. All right, so in this case, we are getting, actually this is interesting, identical to their sequential read numbers. We are getting 517 megabytes per second. So, all right, so let's do a random IO test. So rand read, this was the one I ran earlier. Okay, so instead of the individual devices, we're going to do it on the RAID-0. Let's go. Average IOPS is 211. Okay, so earlier, if you remember, it was like 138 on one side and then like 130 on the other. Let's just say they were both 130. If you add those together, it would be 260, and this is definitely less than that by a fair margin here. So we're not really achieving double the IOPS in this case. Now, again, this might be a result of, like I said, in order to really take advantage of this technology, you have to lay out your data just right between the two sides of this drive, this Mach.2 drive. And so it might be the case that the Linux software RAID-0 isn't optimal for that, because we know each side could have done 130 IOPS. So in combination, it would have been 260, but we're only seeing 211 here. So as far as trying to accomplish the double the performance claim that they're saying, I think it involves a little bit more detail there. I think the exciting part for me is that this allows hard drive technology to really kind of take a huge leap in performance, above where most standard hard drives are. They've kind of been stuck somewhere around the 250 megabytes per second, bandwidth range for many years. And as platter densities have improved over time, that's creeped up a little bit over time, but it's really has been tiny incremental steps over time, while this technology, this Mach.2 technology, is a significant leap forward in terms of throughput. And even in the IOPS arena, I mean, this is definitely a huge improvement as well. So yeah, I'm actually pretty impressed with this stuff. I think it's cool. I think you do need to take into consideration how you're going to be able to take advantage of this dual actuator, the dual head technology, and how you're going to lay out your data. Because if you don't lay out your data correctly, I think the benefits of this will diminish, right? Now, the other thing to consider, especially if you are using things like ZFS or even software RAID, but with parity, is that you probably want to avoid having the same two halves within the same RAID set, right? Because if the motor were to fail and both of those were in the same RAID set, you would basically have two failures in that RAID set. And if you have enough redundancy, you might be fine. But let's say if you went through with a RAID 5 and you lost those two drives in a RAID 5, then your RAID array would be dysfunctional, right? So that's not good. So there needs to be a little bit more care and thinking behind how you're going to utilize the two halves of the Mach.2 drives when you are assembling them in some sort of parity scheme. So whether that's RAID 5, RAID 6, or like in ZFS, RAID Z1, Z2, or Z3. So I think additional considerations need to be made when you're using these Mach.2 drives in those scenarios. Alright guys, that's it for today's video. I hope you enjoyed this video, and if you did, please give me that thumbs up. And if you're new to this channel and you like this sort of stuff, consider subscribing to the channel and hit that notification bell so you never miss my videos. Also, if you want to support my channel, go check out my eBay store. I've got the best selection of pre-flashed IT mode HBA SAS controllers for your ZFS, TrueNAS, or Unraid builds, so go check out the link down in the video description. Thank you very much for watching, and have a great day. Bye-bye.